Now I think we're finally ready. Only a little bit later. So today we're going to go over section 1-2, which is called functions. So I'll let that pull up on your screens for a second. It's the same as in your notes. I'm sure you all have heard of functions before, but it's always a good review. Always one of those questions that get asked on SATs and ACTs. So, and we're going to be obviously working a lot with functions in pre-calculus. So not a bad place to start. All right, so you'll see at the top of the notes, there's two words. There's a relation and a function. So kind of the broad strokes in calculus or in mathematics is that we have a relationship between two numbers. So that could just mean anything from, a set of numbers that's matched to another set of numbers. It could be one data point that's matched to another data point. It's just pairs of quantities. So that's kind of the overall broad term. And then a subset of that is a function. So a function is, well, you can read it right here. A function is a relationship between two variables such that each value of the independent variable there corresponds exactly one value of the dependent variable. Uh-oh, Aiden's audio is cutting out. Is the audio working for everyone else? It's a little better? Okay. Let me know if it's not. I'll try to figure something out. And like I said, there might be some better technology than what I'm using. So I'm open to that too. Okay, so has everybody seen a function before? Function notation, all that good stuff. Anybody there? Hello? Okay. All right, so let's talk a little bit about what a function is and what the function notation is. Okay, so you'll usually see a function written like fancy f of x is how I would read this. And then you'll have we'll make it a really simple function. F of x equals x. Okay. People, when I first introduce functions, usually are kind of like, f of x, where did this come from? So in my, some simplifying math brain, I like to think of f of x as y. It's basically like your y and your typical algebra problem, right? So usually if you have, well, let's make it a little more fancy. Let's make it x plus 1, just so we know what we're talking about. Okay. So usually when you would see y equals x plus 1, kind of in all of our mathematical workings, right? We're used to x being our input and y being our output. It's just kind of how we've learned about equations as we've gone through algebra. So instead of, so this is our input. See, I'm trying to draw on the screen and it's not input. Okay. And we call that the independent variable. And that'll take a little bit for me to write, right? And then y is our output. That's what we get out of the function or the equation. And we call that our dependent variable because it depends on what you put in. All right. So we've been used to this for a long time, right? The y equals x plus 1, because that's kind of what we've done in algebra for a long time. And I know some of you have worked with functions before, so you're used to function notation. But a function has a couple specific things that make it a function, which we are going to talk about, but it's the same idea. So in function notation, your x is your input or your independent variable. You can put any, x from the set into the function. And your y is your output. Your f of x is your output in function notation. So it's what you've seen before, but it's in function notation versus just equation notation. All right. So I said there's a couple specific things that make a function a function. All right. And this has to do with the data set that gets input and output. Sorry, I'm just checking on Adam here for a second. All right. Adam said he's out in the country, so it's going to take him a while. All right. So when we talk about input and output, we're basically talking about the domain and the range. Have you heard those terms before? So the domain is what you're putting in. Okay, great. So the domain, so we've got our input. Another word for this we said was, I should just switch to typing, that would be faster. We have our independent variable, or we have our domain. So that's how, those are all ways that we think about what we're putting into our function, right? And then on the flip side, we have our output. So what comes out of our function, which we could think of as our dependent variable or our range. Okay. So that's what comes out over here. So what things make what are things that make a function unique from just a relationship? So there's a couple things that make it unique, and it has to do with what we put in and what we put out and how they have a relationship to each other. Okay, so the first rule, and you'll see this listed on your paper, it says characteristic function set from A to B. All right, so the first element that makes a function by definition is that, and we'll call this set A, what goes in. And this is set B, if you're following along with your notes. Set B. I got to work on my technology too, because my pen is not working for me today. Okay, so the first characteristic that makes a function is that for every element in A, you have to match it with one element of B. All right? So this is the first rule. So if I put in x equals 1, then my f of x, or f of 1, would be 2. So when I have x equals 1, there's only one value that comes out on the other side. So it has to be matched with exactly one element. The second characteristic says that some elements of my dependent set may not be matched with any element of my independent set. So I'm going to show a visualization of what that looks like. But that basically means set A has to match with something in set B. Set B doesn't have to necessarily match with something in A. Okay. Number 3 characteristic, 2 or more elements in A may be matched with the same element of B. And for the element of A, the domain cannot be matched with 2 different elements of B. All right, so let me draw something. I think it's going to help illustrate what these words mean here. So get my awesome drawing skills, guys. All right, so set A is your input values when they're talking about, and what I'm referring to is on your notes right here, characteristics of a function from set A to set B. So this is what basically makes a function a function versus a relationship. And we'll do some examples, and I think this will be pretty clear to you guys. It sounds like a lot of just words right now. So this is basically like your x. You can think of this in your mind as your x. And I apologize for this horrible writing. I'm writing with the mouse right now because my pen's not working. So set B. And we're going to say, since we want a function, this is like your f of x. Okay. So in set A, let's have a set of numbers. It doesn't matter what numbers they are. Let's say we've got the number 1, we've got the number 2, we've got the number 4, and the number 10. Okay, and in B, we'll just put some random numbers. We've got 10, let's throw a negative in there, -3, 5, no, 100, 8. Oh, let's throw another negative. We'll make it -8. Okay. It doesn't matter what the set of numbers are. We just have a set of numbers in A and a set of numbers in B. Another way that you might see these written is, let's see if I can find the fancy brackets on my computer here. You could see these written as 1, 2, 4, 10. Fancy brackets around it. Like this. So that would be another way that you could see set A written, and the same with set B. All right, so let's talk about the characteristics of a function when we actually have some data up here on the screen. So the first characteristic of the function is that every element in A must be matched with an element of B. So if I put in x is 1, okay, I have to get an output of one of the datas in set B. So if I put in x is 1, I get f of x is 10. If I put in x is 4, then my output is f of x is 5. Okay. If I put in 2, x equals 2, my output is f of x equals 100. This is one crazy function. And if I put in 10, if I can get it to circle, you can do it, computer. If I put in 10, I get f of x equals -8. It'd be a really interesting function to try to define what that function is. But that's the characteristic of each element of A must be matched with the element of B. Number 2 is some elements of B may not be matched with any element of A. So we didn't use -3 from our set B, and that's okay. This still can be considered a function. Okay? I would think so, Sam. I would think this would have to be piecewise to get these function values to work. The third criteria is that 2 or more elements of A may be matched with the same element of B. Okay, so if I put in, I'm trying to think of a function off the top of my head that's like this. There's lots of functions that do. So think about the quadratic function, right? You guys probably have studied that last year in Algebra 2. A quadratic, that's supposed to be a parabola. Okay. A quadratic is a function. So, for example, let's see here. Are you guys following along? Is this hard to follow on here? Because we're kind of in the theory part, right? So if you think about a parabola, right? When I have, and this is a very terrible drawing of a parabola, but when you think about a quadratic function, let's say right here is when x equals 2, my y value, oh, sorry, Aiden, my y value is +1, right? And then on the negative side, when x equals -2, my y value is also 1. And remember, we're thinking about our y value as our function value, our f of x. So rule number 3, or characteristic number 3, says 2 or more elements of A may be matched with the same element of B. So basically, you could put in x equals positive 2, and you'll get f of x equals 1. And you can put in x equals negative 2, and you'll get f of x equals negative 1. So they're matching in this particular set. Negative 2 of set A and positive 2 of set A would both match to 1 in set B. Okay? So you could put in negative 2, get 1. You put in positive 2, you get 1. So it's okay if more than one element of your domain matches to the same element of your range. That makes sense? Ish. Okay. I'll take the silence as yes. All right. And then the last one is, and this is really important. This one, well, they're all important to define a function, but this one kind of is one of those questions, and it has to do with, we'll have another rule that kind of has to do with this, but each element of A, the domain, cannot be matched with 2 different elements of B. So you can put in an x and get the same f of x as a different number, a different x value. But if I put in x equals, let's say 1, back here to my original drawing, if I put in x equals 1, I cannot get out f of x equals 10 or f of x equals negative 3. It's kind of the big no-no with functions. So when you put in an x value, when you put in something from your domain, there should only be one solution from your f of x values. Okay, so kind of back to this quadratic parabola, and my screen is a mess. Oh my goodness. If you, let's see. If you have a equation that graphs out like a parabola like this, remember we looked at those in Algebra 2, at least I know my class did. Okay, so when I put in, this is my, let's see, we'll pick on 3 this time. Okay, if I go to x equals 3, my value, my output value could be, let's say this is 3 up here too. When x equals 3, I could get positive 3 or negative 3, right? Because there's 2 values when x equals 3. So this particular graph would not be a function, because when I put in a single input, when I put in 3, I have 2 possible outputs. So it's a 1-to-1 match when it comes from input to output. Did I totally lose everybody? That makes sense? Have you seen this before? You still with me? You still awake? All right, I got some yeses, so that's good. All right, so I think the easiest way, and there's some other information on here, and we might just do that on Monday, but I think the easiest way to kind of test your, function skills is to look at some data, which is what I have printed out on here. And these were kind of fun to look at because it was kind of like a game, like figure out if it's a function or not. Okay, so let me pull up this. Let me take a screenshot of, oh, I forgot I had the screenshot tool on here now. That's not what I wanted. All right. Good old paint. All right, now we can draw all over these notes. Maybe make them a little bit bigger if I don't distort it too much. Oh, that didn't even work. Okay, so let's look at a couple of these and just kind of see if we can figure out if they're functions or not and why they are or why they aren't. So first we got this one in the circle here, okay? So does this relation describe a function, explain your reasoning? So when I looked at these problems, what I was trying to do is to go through basically what was on the page before of your notes, go through those 4 criteria and see if they meet the criteria of a function. Okay, so we've got some numbers in the domain here. We've got some numbers in the range. Let's see if it's a function or not. Aiden's already saying, nope, this one is not. All right, so then they want to know why. No more can you just say no, right? We got to figure out why. So let's just run through it really fast. Each element of A must be matched to an element of B. We've got that covered, right? -2, -1, 0, 1, 2, they're all matched to an element, right? And that's correct, Aiden. Aiden's already figured it out. It's okay if some of our values in the range aren't matched, which isn't a problem here. 2 or more elements of A may be matched with the same element of B. We definitely have that going on because 1 and 2. So I'm looking at characteristic number 3. 1 and 2 are both matched to 5, but that's okay. You're allowed to do that. But then we get to number 4, and like I said, this is the one that kind of, the big one, I guess, of all 4, is that an element of the domain cannot be matched to 2 different elements of the range. So -1, you'll see, is matched to 3 and 4. So if I put in -1 in my function, I don't know if I'm going to get out 3 or 4. So that makes this not a function. As Aiden said, -1 goes to 2 different values in our range, so this makes it not a function. I kind of ran through those steps quickly. Does that make sense to everybody? Yeah? Awesome. All right, so then what do you think about this one here with the, oh, how appropriate, number of North Atlantic tropical storms and hurricanes? Yeah, I totally planned that, guys. What do we think about this green circle here? So we have our domain, which is the year. That's what we're putting in. And then our range is the number of hurricanes that we get every year. That's a crazy 26 on there. So let's run through the characteristics. Each element of A must be matched with the element of B. That just sounded crazy. Yes, so every year has a number of hurricanes associated with it. So number 1 is good. Number 2, some elements of B may not be matched with A. So that's not a problem. Everything's matched up. 2 or more elements of A may be matched with the same element of B. We have that going on with the year 2000 and 2001. There was 15 hurricanes in each of those years, so 2 years in a row. And then number 4, an element of A cannot be matched with 2 different elements of B. So if we look here, every year has just one value associated with it. So we would say, yes, this is a function. Isn't that exciting? We've got some functions. So fun, right? I can hear the excitement over your microphones. How exciting this is, right? No. Hooray. Yes, I just hear it in the chat. Oh, okay. You're just so excited. Yes, it's thrilling, right? I actually thought number 10 was kind of fun because you have to, like, they have it written in a different notation. 6 and 8, I think you guys can do no problem. If you want to type what you think it is, that's fine. I'll tell you. But number 10, and these are all just written different ways. These are all sets of data, domains and ranges, the inputs and outputs. They're all all the same terminology. They're all just written in the same way. So here you have the domain and range written with nice arrows. Here you have the domain and range in a little chart. So if you want to draw it out like this, you can. And here in number 10, we have it written as basically order pairs. So we've got A consists of the set of A, B, and C, and B consists of 0, 1, 2, and 3. So they're saying if, this is basically my domain. I'm just going to write D for domain so you don't have to watch me painfully write that. And this is my range. So let's look at some of these and kind of see. These took me a little bit longer to do. Not super long, but so again, you go through your rules, right? What's the first one? Each element of A must be matched with an element of B. So if I look at little a right here, I'm doing problem A right here. And actually, before I even go through all my steps, can anyone see what the big red flag is for 10A? We've got a set of A1, C2, C3, and B3. Does anyone see what the glaring thing is here? What about when I put in C? What am I going to get out? Exactly, Jennifer. If you put C in, you could get 2 or 3. And that's the big no-no for functions. I mean, there's other no-nos, but that's the big one, right? That's what we're talking about. Number 4. When you put in a domain, when you put in an input value, you should only get one output value. So we know without even going through our 4 steps that this is not a function. And actually, if you go up here to 6, you kind of have the same situation. If you they trick you by the way they write this chart. But if you put in 1, you could get -2. And if you put in 1, you could get +2. And if you put in 0, you could get -4 and 0, +4. So this kind of has the same problem. That number 4 is the one that's going to get you, not a function. Okay. Aiden votes that B and D are good. Aiden, I agree with you. B is good. That's easy peasy, right? A matches to 1, B matches to 2, C matches to 3. We didn't use 0, but that's okay, right? Because our criteria number 3 says not everything in our range has to match. So that's good. Same with D. D is good. All right, what's up with C? Function or not? Yep. Why is that? There is 2 A's. Yeah, we switched the input and output, right? If we switched, well, yeah. You know what? I don't even know if they specify that. Now that I look at it. If we, yeah, what they did is they switched the input and the output, right? So they're making a relationship between A and B, but I just assumed that A was the input and B was the output, and they actually did not specify that. I just kind of assumed it based off of their previous things. Well, so if we do assume that A is the input and B is the output, then is this a function? No, right? Because they've switched it. They've put in the range and the domain. If we assume that you can switch it, then let's see. 1, 2, 3. They're each matched to a value. So if you do assume they could switch it, then it would be a function. All right. Fun with functions, right? Yes? It's a blast? Yeah, so fun. Yay. I'm glad that you're cheering still. All right, I see that we're up to 9:51. I think there's one or two that we can do really quick so that, and I think you probably could get to most of your homework anyway. We didn't talk about two of these problems, but let's maybe go for 4 more minutes and then I'll let you guys head on your way. All right. I forgot that I got this tool. And we've got a piecewise function in there for you, Sam. Yay. All right, so another way we're going to look at the we're going to look at functions is we're going to actually look at some equations, and we're going to say, does this equation, whether the equation represents y as a function of x. So basically, these are in, you know, just equation terminology. We're going to say, could this be a function based off of the equation? So how would we do this? Well, the biggest thing is that you're going to want to do when you're algebraically looking at this is you're going to want to solve for y. So off the bat, number 16 is, 16, 24, those are going to be easy to look at. We've got to do a little work to 14 to see if we think that that's a function or not. So let's do 14 down here. Maybe. Come on, pen, you can do it. All right, so 14 says x equals y squared plus 1. And we're trying to see whether y can be a function of x. So they're telling you that x is the domain, x is the input, y is the output. So if we rewrite this equation, and I apologize. Let's see here. I'm trying to write. There we go. So much easier if I can write on the screen. Okay. So I'm going to rewrite this as y squared equals, come on, pen, y squared equals x minus 1, right? And then in order to solve for y squared, in order to solve for a single y, I am going to take the square root of both sides. So I'm going to square root this side, and I'm going to square root this side. The thing with square rooting is that you have to remember that there is a positive and a negative square root. So y equals positive plus or minus, sorry, I'm just having problems with my pen, x minus 1. Okay, so all I've done in 14 so far is I've rewritten my equation. Y equals plus or minus square root of x minus 1. You guys okay with that? So now that I look at it like this, is this equation a function? So if I put in x equals 1, 1 minus 1 is 0. That's a bad example. So let's put in something easier. Let's put in 10. X equals 10, right? 10 minus 1 is 9. Square root of 9 is 3. But we have this plus or minus value here. So if you put in x equals 10, y could be positive 3 or negative 3. So for one value of x, we get 2 possible values for our y. So this actually makes it not a function. So one of the things I want to show you super fast is, let's see, if I go to Desmos, and I graph my original equation. So y equals x squared, or no, in my head, x equals y squared plus 1. Okay. So what you see here is you have this nice, beautiful parabola. But unfortunately, when we put in a value of x, we have 2 different values of y. So if we put in x equals 10, we get y equals, you guys get it. I can't get my cursor there. Oh, come on. There we go. X equals 10, y equals positive 3, and x equals 10, y equals negative 3. So there's two possible values. So this would not be a function. So I wanted to throw that up there really quick because I know our time is coming to an end. But we can look at these functions. It's a mess there. We can look at these functions algebraically and just kind of see, does that look like it would be a function? Or we can look at it graphically. That can help us out too. All right. So if you look down your list, like 16, for example, does not have the plus or minus square root. So that would be a function. What do you think about 18? Just move some things around. We're going to end up with y equals 5 minus x, right? So I think 18 will be a function as well. So I think that should be enough to get you started. We'll finish up on Monday. I really, really appreciate you guys sticking with all the technology stuff in the beginning. If we can't get Adam connected, and Aiden, I know that you've, like, I hope that the connection worked okay, but if not, we'll come up with another way to connect better. And if anyone has any suggestions of stuff that they use that they think would work well, I'm open to that as well. So thank you guys for sticking with me today. I'll see you guys all on Monday. I hope you have an awesome weekend. All right, awesome. Oh, is that you on here, Adam? Awesome. Have a great weekend, guys. I'm glad you were all able to join. See you later. Oh, and you can watch this again on YouTube.